Oh, good morning everybody. Today we've unlocked new colors as you can see. Anyway, today we're going to be reviewing geology and we've gotten improvements today. So if anyone has concerns about the material that I use to provide this review for you all, I'll kindly attach it in the description so you guys can go see that too. And it'll just be exactly like what I'm teaching you in this video. Without further ado or any more wait, let's get into it. First off, we're going to cover soil and water. So our first subtopic will be the importance of soil to plants. So what's the importance of soil to plants? Imagine you have soil here, right? Now, you have a plant. Just gonna draw it like this, right? You got a plant here. That plant is going to grow some roots. Yeah, so the importance of soil to plants is that soil is anchoring the root of the plant. So that's why soil can be really important to plants. Now let's go look at how soil is formed. But first, let's denote a few terms. OM and IM. For OM, it means organic matter, and for IM, it means inorganic matter. So I'll just put that so no one gets confused. So soil formation comes from inorganic matter and organic matter, in which they combine to make soil. Additionally, the inorganic matter is the parent materials. And that's one thing that makes soil. And organic matter is remains of living things or living things that are still living. Okay, now let's go look at soil profiling and soil horizons. Okay, let me draw it out real quick. So the first layer, this is the organic layer, otherwise known as the O horizon. Next up, we're gonna cover the topsoil layer. So this is the layer where there's topsoil, otherwise known as the A horizon. Now let me draw a plant here, because this will be important for later. As we know, the soil can anchor the plant root, and the plant root is actually going to go down a lot. So let's dive right into what the third layer is. The third layer we refer to as the alluviation layer. Or otherwise, we call it the E horizon for short. Now B, what's B? Okay, sorry, it's not supposed to go that far, but this is the subsoil layer, otherwise known as B horizon. Now, the C layer, or parent rocks. This is the sea horizon, or otherwise known as the layer of parent rocks. Now, the deepest layer, bedrock, or as we otherwise known as the R horizon. And that is soil profiling and horizons done. So let's erase this and go to the next topic. The factors of soil formation. What do you think would be the factors that allow soil to form? Can you name me a few? Pause the video to think about it and see if any of your answers are correct. First off, plants and animals are a big factor because, as we said, soil is formed from organic matters and inorganic matters. Time is also a big factor. The topography of certain land is also a big factor. So is parent materials and the climate. Because if soil is forming in a wet season and another soil is forming in a dry season, it won't be the same. Now, let's look at saline soil. What's saline soil? It's a soil that contains an excessive amount of soluble salt. So that's what saline soil is. Now let's look at the soil properties. So the soil properties, for example, if I want to give a nice example, let's go search it up on Google, right? Soil properties chart. So if we go look at this, I'm going to get an image that's somewhat high quality. Not that one. This image right here. We're going to copy that image in. Can I paste it? No? Okay. So the sandy clay loam would be like 20% silt, 30% clay, and 50% sand, right? We can see here it's at 20% silt, 30% clay, and 50% sand. Oh, sorry. That's actually at clay. That's at clay, yes. Oh wait, if we go look in the actual site itself. Can I write with this thing? Like on the thing, please, oh my god! Okay. Let's not get sidetracked. Let's look at the sources of water on Earth now. Oh, sorry, I'm sick. So there's fresh water, right? Then there's salt water. And then there's ground waters. And subsurface waters. So you can pick or obtain subsurface water with what we call an artisan well. So this is the artesian well. The spelling might not be correct, but you get my point. Now, let's look at the zones in soil layers. The first zone we will refer to as a zone of aeration. Let's use a better color so that you may see it more clearly. So this right here is the zone of aeration. Then here's a blue zone, which is saturation. So what's the difference between these two? First off, aeration is we have these particles, right? In between these spaces, there's air. For saturation, we have the same particles, but in between these spaces, it's getting filled up with water instead of air. So that's how zones in soil layers work. Okay, now let's look at gases and acid rain. So gases and acid rain, we can have 3 kinds of acids in acid rain. The first one being carbonic acid. The second, sulfuric acid. And the third, nitric acid. Now, I'll also provide the formula for this. So it's H2O, right? It's H2O plus CO2 into H2CO3, making carbonic acid. So now sulfuric acid, we have H2O, SO2. So it's sulfur dioxide plus water. And with residue of oxygen, we can make sulfuric acid, H2SO4. As for nitric acid, it uses water too. So we have nitrogen dioxide, and it turns into nitric acid. And that's gases and acid rain. Now, we're still not over the topic of soil and water yet. So we're going to go look at our last topic, which is the marshes in Thailand. So what do you think about marshes in Thailand? There are a lot of well-known marshes in Thailand, such as the Borapech Marsh. Let's draw it right now. So the Borapech Marsh is connected to the Nan River and the Ping River. Let me write these down. It's connected to the Nan River and the Ping River. And then the structure of the marsh goes on something like this, right? And in here we have exotic fish. Then there are migratory birds. So we have exotic types of fish in the Borapech Marsh and the migratory birds. Now, to clarify even more, it's spelled Borapeth. Yes, so this is the Borapech Marsh in Thailand and the connections it has. Okay, now that we have gotten that over with, let's go look at our next topic, which is natural disasters in Thailand. Okay, so this is our next and final topic for today. Let's first go look at floods in Thailand. So what are the types of floods in Thailand? We have the overbank flow, the flash flood, and irregular flooding. So the flash flood is the flood is coming from a high ground. An overbank flow means it's flowing from a water source. The flooding means it will happen in a city. So imagine these are the barriers that are trying to prevent the flooding. And then this is the water that seeps in. And that is how flooding happens. So those are the types of floods in Thailand. Let's look at coastal erosions in Thailand. So coastal erosions in Thailand are affected by a lot of coastal storms. They're also affected by surges, flood, and tsunamis. Okay. Now, coastal erosions destroy sand dunes and lagoons. Okay. Now let's go take a look at sand dunes and lagoons. First, let's take a look at sand dunes. So this is how a sand dune may look like. Let's use a color that you can see more clearly, if you can't see that one clearly enough. So, assuming that you can see this one clearly enough now, here's grass on top of our sand dune that is growing roots. Right? Then we have plants here. These are goat's foot plant. Otherwise, we know these in Thai as something else. But in English terms, we call it the goat's foot plant. Then, there's more grass here. So this is how a sand dune might look like. Now, here's a sand dune at the beach. So imagine we have water here. Now, let's draw the sand dunes. So, really quickly, I drew these. Now, in here, there are shrubs, right? And near the shore, there will be grass. Then these are new terrain and old terrains. So that's how the sand dunes will look like at a beach. Let's erase this and move on to lagoons. First, let's look at the side view of a lagoon. So the side view of a lagoon looks like this. And in here is the waters or the liquids that may be in there. So the lagoon that we have here is actually a volcano chamber. Okay, let's zoom out so I can draw even more. So we're still looking at the lagoon from a side view. So this time, we can see the erosion that is happening inside the lagoon. And the liquid is still in there. The liquids that it contains. Now, we're gonna go look at the lagoon from a top view. So this is how the top view might look like. And as usual, there's water in here. Or any other liquids that it may hold. Now, from here, it can erupt. So after the eruption, it will look something like this. After the eruption, you can see this space opened up more. And that is our lagoon. Okay. Now, we're gonna have a bit of a deeper dive on coastal erosion. So let me draw out a thing. So you can see here, this is the slope. Let me write it in a clearer color. Alright. Then here is the cliff, and these are the waves that are causing coastal erosions. So that's it for coastal erosions. Let's go look at landslides. So landslides, they usually happen when you build something on land and it happens to form cracks in the land. Say for example, you have a house here. But now look at that. That house it has these supporting poles in the terrain, right? Over time, it can form cracks. Now let's get our little man here. We're calling him Little John. Little John is the owner of this house. He doesn't know what's coming next. Then the land slides, right? It's sliding from its original place. And that is because the house poles underground had formed a crack. So now Little John is in danger. Oh, Little John! R.I.P. to Little John. So that is how landslides may form. And no Little Johns were harmed in the making of this video. So now we're going to look at preventions of natural disasters. One way we can prevent landslides is by growing vetivers for a deep root system on the mountain. So let's have a deep dive on that. So this is the concrete surface that we will make along mountains. Now, if you're a Thai citizen, you may have seen these while you were driving, right? You got your car, and you and your parents are just chilling there. You're looking outside. Holy shit, what is that? Right? So that is basically the deep root system, where we emphasize on the growth of vetivers so they can collect water. I'll briefly explain how it works. So imagine we have our vetiverse here. Alright. Here's a little indicator. That's our vetiverse. Now, what are these? GTT. These are the pipes. So these pipes, they're going to pump out water. And then there's gonna be more vetiverse below here, so they can collect the water and keep growing. And that is one of the ways we can prevent landslides. Alright. Let's go look at the prevention of coastal erosion. How do we prevent coastal erosions? So let's see. We have our land here, right? Then we have these things that we call breakers, or groins, or jetties. So I'm going to draw in 3 of them as an example. So we have these. They actually have 4 terms. A breaker, a groin in a different spelling, and a jetty. For this video, we'll be referring to them as a breaker. Now here's the waters. Wait, shit, too blue. Here's our waters, right? Now, this is when nourishment comes into play. When we're talking about nourishment in this field, we're referring to the transplanting of soil and sand into the shoreline with erosion. So we transplant soil and sand into the shoreline with erosion, and that is basically how it works when nourishment comes into play. And these breakers, they prevent coastal erosion, as I've stated before. Now let's go look at another 2 things that we're going to talk about today. The sinkhole. The sinkhole is caused by underground destruction of carbonated rocks. Here's our carbonated rock, right? It's full of carbon. So the rocks are full of carbon, and then when they are destructed in any way, they can form sinkholes. Right? So that's how the sinkhole works. Now let's look at land subsidences. It's basically when a large amount of groundwater is withdrawn from certain types of rocks. So let me draw some rocks here as an example. So the groundwater is in these rocks, right? Then they are withdrawn from those rocks, causing land subsidences. Anyway, that will be all for our geology review. Yes, that will be all. And as I've stated before, at the start of this video, materials will be attached in the description for anyone who wants it, or for anyone who has concerns regarding the information I provided in this video. So thank you for watching and have a great day. Goodbye.